Welcome to chemistry classes. In this video we are going to discuss part 4, electrochemistry part 4. Here first we have to discuss calculation of degree of dissociation of weak electrolyte. Degree of dissociation represented by alpha. Alpha can be calculated by molar conductance of a solution at particular concentration divided by molar conductance at infinite dilution. That's mean alpha equal to delta C divided by delta 0. We will solve problems related to this later. Okay. After this next one we have to discuss here calculation of dissociation constant of weak electrolyte. Dissociation constant K. Dissociation constant K equal to C alpha square minus C alpha square divided by 1 minus alpha. This is the equation to calculate dissociation constant of weak electrolyte. K equal to C alpha square divided by 1 minus alpha. We already discussed alpha mean delta C divided by delta 0. Substitute this value over here. We will get final equation C delta 0 divided by delta 0 times delta 0 minus delta C. Here C mean concentration of the solution or concentration of the weak electrolyte. Okay. Next one we have to discuss here electrolytic cell. Electrolytic cell means cell which convert chemical energy to electrical energy. Cell it convert chemical energy to electrical energy. Also electrolytic cells work under external supply of energy. It need external energy to work. Okay, and here in this diagram you can see here there is battery cells. Here big line represent positive terminal and small line represent negative terminal of battery. Also you can see there are two electrodes. There are two electrodes in the solution. One electrode connected with positive terminal of battery with a positive charge. This positive electrode called anode, and another electrode connected with negative terminal of battery and it has negative charge. Negatively charged electrode called cathode. Anode and cathode. Okay, and conducting solution or conducting liquid material, that is electrolyte. Electrolyte mean substance it pass electricity by its dissociation. Okay. Electrolysis. There are two types of electrolysis. Electrolysis of molten substance and electrolysis of aqueous substance. Electrolysis of molten substance mean substance like ionic compounds after strong heating it melt. For example, sodium chloride NaCl, it is solid state. After strong heating it will melt and change to liquid form and it form Na plus and Cl minus ions. Positively charged ions are called cations. Negatively charged ions are called anions. Cations mean Na plus, anions mean Cl minus. Also we know opposite charge will attract each other. Na plus attract towards cathode. Cl minus attract towards anode. Okay. So here reaction taking place at cathode. Na plus receive electron and it will change to Na. Na will deposit at cathode. Similarly Cl minus lose electron and chlorine Cl2. Chlorine it is diatomic, so we have to say Cl2. So chlorine gas will be deposit at anode. So reaction taking place at cathode, reduction takes place. Reaction at anode, oxidation. At cathode, reduction takes place. At anode, oxidation takes place. So overall reaction is redox reaction. Overall reaction is redox reaction. Redox reaction means there is reduction and oxidation. Okay. Next one, we have to discuss here electrolysis of aqueous sodium chloride. Aqueous sodium chloride. Aqueous sodium chloride means sodium chloride and water. Aqueous means water. Okay, so sodium chloride, after ionization it form Na plus and Cl minus ion. Water, after ionization it form H plus and OH minus ions. So there are two cations and two anions. Na plus and H plus are cations. So there are two possible reduction reaction at cathode. Na plus change to Na, H plus change to H2. There are two possible reaction at cathode. But one with a higher electrode potential will be reduced at cathode. Na plus to Na, its E0 value minus 2.17. 2H plus change to H2, its E0 value 0 volt. So here higher value H plus to H2, higher E0 value H plus change to H2. So hydrogen gas will be deposited at cathode. Okay. Similarly, there are two anions, Cl minus and OH minus ions. Also, there are two possible oxidation reaction at anode. Cl minus lose electron and change to Cl2. OH minus oxidize to water and oxygen gas. Okay. So, one with the lower value will be oxidized at anode. So, here lower value, here Cl minus change to Cl2. Its E0 value positive 1.36. Similarly, OH minus lose electron and change to water and oxygen. Its E0 value positive 1.23. So, one with the lower value OH minus change to water and oxygen, its E0 value is lower, and there is more possibility. So OH minus will be oxidized at anode, but actually OH minus is not oxidized at anode. Okay, so here we discussed there are two anions. Which are two anions? Cl minus and OH minus are anions, and there are two possible oxidation reaction at anode. Okay, and one with the lower value will be oxidized at anode. Here OH minus change to water and oxygen, its E0 value is lower and more chance to oxidize for OH minus. But actually OH minus not oxidized at anode. In actual practice, OH minus is not oxidized at anode, because for oxidation of OH minus it need high voltage needed. That's why Cl minus oxidize at anode and forms chlorine gas. Okay, so here at anode there are two anions are here, Cl minus and OH minus. So normally one with the lower value will be oxidized at anode. Here OH minus has lower value, but it will not oxidize at anode because oxidation of OH minus needed higher voltage. Okay, that's why oxidation of OH minus do not takes place. Oxidation of Cl minus will take place. Okay, Cl minus oxidize and it forms Cl2. So at anode chlorine gas formed. Also here the net equation for this cell reaction is given 2NaCl plus 2H2O giving 2Na plus 2OH minus plus H2 and Cl2. So for this chemical reaction, product formed hydrogen and Cl2. H2 formed at cathode, Cl2 formed at anode. These are the product of this electrolysis. Okay. Okay, next one we have to discuss here, electrolysis of aqueous copper sulfate solution. Aqueous copper sulfate and water. Copper sulfate, after ionization it forms Cu2 plus and SO4 2 minus ions. Similarly, water after ionization it forms H plus and OH minus ions. Okay, so here also there are two cations and two anions. Two cations means Cu2 plus Cu2 plus and H plus are cations. Okay, so here Cu2 plus has higher E0 value, so Cu2 plus will deposit at cathode. Cu2 plus reduce at cathode because its E0 value is higher than H plus. Okay. Similarly, at anode there are three possible oxidation reactions. We know there are two anions, SO4 2 minus and OH minus. Okay. Also, here you see this diagram. Here one container with aqueous copper sulfate and there are two electrode, anode and cathode. Both anode and cathode is made of copper anode and copper cathode. Both cathode and anode is made up of copper. Okay, so at anode there are three possible oxidation reaction. Oxidation of SO4 2 minus, OH minus. Also another possible oxidation reaction. Here anode is made up of copper. This copper lose electron and change to Cu2 plus. Cu lose 2 electron and change to Cu2 plus. These are the three possible oxidation reaction at anode. Okay. Here oxidation of Cu to Cu2 plus has higher tendency, higher possibility. That's why oxidation of copper takes place at anode. So here we discussed there are two pairs of cations and anions. Okay, Cu2 plus and H plus. E0 value of Cu2 plus is higher. That's why reduction of Cu2 plus will take place at cathode. Cu2 plus receive electron and copper will be deposit at cathode. This is the reaction at cathode. Similarly, at anode there are three possible reaction. SO4 2 minus, OH minus and another one oxidation of copper anode. Copper lose electron to Cu2 plus. Here higher tendency oxidation of Cu to Cu2 plus. Oxidation of Cu change to Cu2 plus. This reaction more possibility. That's why oxidation of copper takes place at anode. Okay. So at same time copper will deposit at cathode. Equal amount of copper will be liberated from copper anode. Copper anode dissolve and Cu2 plus will be released into aqueous solution. This Cu2 plus will be deposited at cathode. Okay. Next one we have to discuss here, Faraday's laws of electrolysis. First one, first law. First law of Faraday's law of electrolysis. According to first law, W directly proportional to Q. W mean amount of substance deposited at the electrode directly proportional to quantity of electricity passed, quantity of electricity Q. Okay, according to first law, W directly proportional to Q. Or W equal to ZQ. W equal to ZQ. Z represent electrochemical equivalent. So according to this law, amount of substance deposited at electrode directly proportional to quantity of electricity passed. quantity of electricity passed represent Q. Q also equal to IT. Q equal to IT. I mean current in ampere. T time in second. So W equal to ZQ. Here Q is IT. So we can substitute these values over here. Finally we can say W equal to ZIT. Okay, W equal to ZIT. If the current passed is 1 ampere in 1 second, means the value of I 1, also the value of T is 1. So we can say W equal to Z. So electrochemical equivalent will be equal to amount of substance deposited at the electrode if the value of I and T is 1. Okay. Next one we have to discuss here Faraday's second law of electrolysis. Faraday's second law. See here this diagram. Here two container, each container contains electrode. In first container it contains aqueous Cu2 plus. Second container there is aqueous Na plus. Okay, Cu2 plus ion and Na plus ion. Okay, when we pass same quantity of electricity in both electrode, in both container, then according to second law of electrolysis, according to Faraday's second law, we can say W1 divided by W2 will be equal to E1 divided by E2. What does this mean? W1 mean weight of copper ion deposited, mass of copper ion deposited. W1 mean the first container there is Cu2 plus. Okay, so W1 mean mass of copper deposited at the electrode divided by W2, mass of Na plus deposited at the electrode. It will be equal to E1 divided by E2. What do you mean by E1 and E2? E1 mean equivalent weight of copper. E2 mean equivalent weight of sodium. Okay, so the ratio of W1 divided by W2 will be equal to E1 divided by E2. This is second law of Next one we have to discuss here batteries. Batteries are easily portable source of energy. Easily portable source of energy, that is batteries. Batteries, it convert chemical energy to electrical energy. It convert chemical energy to electrical energy. And here some certain criteria for batteries. Here the batteries should be light so that it can carry one place to another place. Second one, the voltage of battery should be constant. It should not vary. It should not vary frequently during its usage. These are the certain criteria for the usage of batteries. Batteries should be lighter so that it can transport one place to another place. Second one, its voltage should be constant. Do not vary its voltage frequently during its usage. Batteries. So there are two types of batteries, primary batteries and secondary batteries. Now we are going to discuss here primary batteries. Primary batteries means the batteries it can use only one time. It cannot use again and again by recharge. Such type of batteries are called primary batteries. In primary batteries, chemical reaction takes place only one direction, only once. After that chemical reaction, the battery will be dead and it is useless after that chemical reaction. That's mean primary batteries can use only one time. Okay, example for primary battery, dry cell. Dry cell is one example for primary battery. Here see this diagram showing primary battery. Okay, inside this part, inner part of this dry cell, there is carbon rod. Carbon rod. Okay, this carbon rod surrounded by mixture of manganese dioxide and carbon black. Manganese dioxide and carbon black. This mixture of manganese dioxide and carbon black surrounded by mixture of ammonium chloride and zinc chloride. Ammonium chloride and zinc chloride. Also all this mixture included in a container. This container made of zinc metal. Okay, so there is carbon rod surrounded by mixture of manganese dioxide and carbon black. It is surrounded by mixture of ammonium chloride and zinc chloride. All this mixture, all this included in a zinc can. Okay, and what are the chemical reaction taking place here? Reaction at anode. We know oxidation takes place at anode. Zinc oxidized to Zn2 plus. At cathode, reduction of manganese dioxide happen. Okay, at anode, electron released and this electron received by manganese dioxide and its reduction happened at cathode. Also here overall cell reaction given. Okay, so here the final product ammonia formed. Okay, ammonium chloride changed to ammonia during this chemical reaction. Also the voltage of dry cell is between 1.2 to 1.5 volt. This is the voltage range of dry cell, 1.2 to 1.5. Next one we have to discuss here secondary batteries. Secondary batteries mean batteries it can be used again and again by recharge. Here chemical reactions are reversible so that we can recharge this battery and we can use again and again. That is secondary batteries. Example for secondary batteries, lead storage battery or lead storage cell. Lead storage cell. The different parts of lead storage cell is dilute sulfuric acid. Dilute sulfuric acid used as electrolyte. Here sulfuric acid water ratio is 1:3 ratio. In dilute sulfuric acid water ratio 1:3. And positive electrode used here lead peroxide, PbO2, lead peroxide. Similarly, negative electrode used pure lead used negative electrode. And here chemical reaction taking place at anode. At anode oxidation of lead takes place. Pb changed to PbSO4. Oxidation of lead takes place. Reaction at cathode. Reduction takes place at cathode. PbO2 lead peroxide changed to lead sulfate. Reduction. Here PbO2 reduced. Also here overall reaction given here. Next one we have to discuss here mercury cell. Mercury cell also example for secondary battery. Here different parts of mercury cell is anode. Anode is zinc amalgam. That is mercury. That is anode. Cathode is made of a paste of HgO and carbon. Cathode is paste of mercury oxide and carbon. Electrolyte is paste of potassium hydroxide and zinc oxide. These are the different parts of mercury cell. Anode is made of zinc amalgam, cathode is paste of mercury oxide and carbon, and electrolyte is paste of potassium hydroxide and zinc oxide. These are the different parts of mercury cell. Here reaction taking place at anode. We know oxidation takes place at anode. Zinc amalgam changed to zinc oxide. So zinc amalgam oxidized. At cathode reduction takes place. Here HgO reduced to Hg. Mercury oxide reduced to mercury. Okay, also here overall reaction given. In overall reaction, there is no ions. There is no ions in overall reaction. That's why the concentration of the solution change. That's why the voltage of the cell remain constant throughout the life. Here overall reaction given. In overall reaction there is no any ions. There is no any ions in solution. That's why its concentration change. Concentration of the mixture will change during its chemical reaction. That's why its potential difference remains constant during cell reaction or during the usage of this type of battery. Okay, here voltage of mercury cell remains 1.35 volt. This is the voltage of mercury cell, 1.35. Nickel cadmium storage cell. This is another example for secondary battery. Nickel cadmium storage cell. Here different parts of nickel cadmium storage battery. Anode is made up of pure cadmium and cathode is nickel oxide hydroxide. Nickel oxide hydroxide. And electrolyte is made up of potassium hydroxide. Potassium hydroxide. And here the potential difference, the voltage of nickel cadmium battery is 1.2 volt. 1.2. Compared to lead storage battery, nickel cadmium battery has small size, also it is lighter. It is small, lighter, so it is easily portable. It is easily portable compared to lead storage battery. And also it has large life. It stays longer time compared to lead storage battery. But disadvantage, it is highly expensive compared to lead storage battery. Nickel cadmium battery highly expensive. Okay, advantage, it is lighter, smaller, and it has large life. And here the chemical reactions. At anode, cadmium oxidize. Oxidation of cadmium takes place. Cadmium changed to cadmium oxide. And reduction, nickel trihydroxide reduced to nickel dihydroxide. And overall reaction given here. These are the things we have to understand about nickel cadmium storage cell. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.